is 54x squared over 5. Set the derivative equal to 0. Solve for x squared. Square root both sides of the equation to find values for x. Since dimensions can only be positive real numbers, x equals 10 over 3. To find the dimensions, substitute into the formula to find h. h equals 20 divided by 10 thirds minus 3 times 10 thirds all over 5. The height of the box is 4 centimeters. By substituting 10 over 3 for x, we find the sides to be 20 over 3 centimeters and 10 centimeters. So for the box to have a maximum volume, the dimensions must be 10 centimeters by 20 over 3 centimeters by 4 centimeters. We can use the second derivative to check that the volume is a maximum at x equals 10 thirds. This second derivative equals negative 54 fifths multiplied by 2x, which equals negative 108 fifths multiplied by x. When x equals 10 thirds, the second derivative equals negative 72. Since negative 72 is less than 0, the volume is a maximum at x equals 10 thirds. Finding the gradient of a curve at a single point. Recall, to find the average gradient between 2 points, we use the formula m equals the change in y values, delta y, divided by the change in x values, delta x, which equals y2 minus y1 all over x2 minus x1. We can determine the average gradient of the curve, where h is the horizontal distance between the 2 points, by drawing a secant through the points with x coordinates of x and x plus h.
Want to catch up on some of your studies? Join Mindset for late night studies. Monday is mathematics, Tuesday is physical sciences, with life sciences on Wednesday and accounting on Thursday. Friday is English, maths literacy on Saturday, and Sunday is a good day to catch up on geography. Every day from 9 p.m. till midnight, and again from midnight till 6 a.m. Late night studies, only on Mindset.
A very, very warm welcome to all of you Tenfolders. Welcome to another epic edition of Tenfold Live, a show that is proudly brought to you by Liberty. My name is Sibusisa, and as always, we always express how grateful we are and how happy we are to welcome you on a show that is going to be focusing on the mathematics revision, where we'll be looking at all the questions that you have across paper 1 and paper 2. We know it's time for exams now, and you guys are very much interested in revising all these concepts combined. Remember, like we always say to you, if you haven't done so, just go to your app store and look for what we call the Tenfold Education app. It is an awesome app packed with a lot of very useful resources. It will help you to stream this show live. In addition, it will also help you guys to send questions to us. Maybe you are wherever you are and you want to know how you can send questions to us. Just use this app, send questions through. In addition to that, you can also use this app to watch videos that we have on content that help you build yourself up as you're trying to understand all the background information that we are using as we're answering your questions. Beyond that, if you go to WhatsApp and you send us a greeting, there is our bot there, Dex, waiting with a whole lot of very useful resources as well. Dex will help you guys with very, very useful resources. You'll get access to past papers that you can use, including questions that we're using on today's program. You probably want to have them and use them as we're also going through with this show. Maybe you want to practice with me or try to answer the questions as I go through. Do make sure that you download, you actually send that greeting to us. We'll actually be able to hook you up with all those awesome resources. Perhaps you want a person who likes videos. Just go to YouTube, find us there. We are Mindset Learn. Like our videos and also subscribe to our channel, guys. It's an awesome channel. Invite as many people as you can to also go there and feast on all that we have for you in the form of videos covering all possible concepts that you could be interested in. But on today's edition, which I call the Express Hybrid Edition of the Math Revision, we will be focusing on any question that touches on both paper 1 and paper 2. I saw very exciting questions that you sent to us. They are on trigonometry, Euclidean geometry. There's a lot of things, and you don't want to miss any of what is going to be going down in today's program. So without any further waste of time, let's jump right into our first question and see what this one is basically about. Right, so this would be question 3, and clearly, just by the look of things, you will see that this is a question that is based on the concept of trigonometry, one that is basically very challenging for a lot of matriculants. So I hope after you've watched this particular segment, you'll be able to do a lot of damage when you get these kinds of questions. This is what I call general trigonometry, and actually touches on trig identities, it touches on compound and double angles, it touches on the definition of trigonometric ratios, where the sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent comes from. And the very first question is literally about that particular concept. Okay, so it reads as follows. It says, if 5 cos of x equals 4, and x is an angle between 90 degrees and 360, determine the value of 3 sine 2x without using a calculator. A pretty awesome question. We are asked to find the value of 3 sine 2x without using a calculator. Don't confuse these things. We are interested in finding the value of that. But then someone is asking, what is the purpose of telling us what you told us here? What's the role of this, right? The role of this is just to help you to build a right-angled triangle that you can feed sides and then use it to try and find the value of 3 sine 2x. So now, the first thing we'll do is hunt what I call the arete. There's a arete here, grade 12s, which is a right-angled triangle. It's going to be hiding in one of the 4 quads. So let's draw those 4 quads. I think you guys should know that in the first quad, all trig ratios are positive. In the second quad, sine is positive. In the third quad, tan is positive. And in the last quad, cos is positive. So what are we looking for? We are looking for the ratio where if I just make cos of x a subject here, you'll agree with me, we're going to get the number 4 divided by 5. And that happens to be a positive quantity. So we're going to have our rate, and our rate is hiding in a quadrant where cosine is positive, because the result I'm getting from this, when I make cos a subject to the formula, is a positive result. So where is that? So that's likely going to be in the 4th quadrant, which is a quadrant where cos is positive, or in the 1st quadrant, which is a quadrant where all of them are positive. So still not conclusive. It could be in any of those 2 quadrants, right? Now we run to the second part, which I'm going to highlight in blue, which is exactly this part here that says our angle has to be a number between 90 degrees and 360 degrees. And you guys know from this cast diagram, 0 degrees is going to be here, 90 degrees is right there at the top. So if I put 90 here and I put 180 here, and we'll obviously have 270 here, and then eventually after a full revolution, we're going to end up at 360 degrees here. So according to this statement, The angle we're discussing here is between 90 and 360. So that clearly tells you that the first quadrant is off. So our diagram cannot be in the first quadrant because angles in the first quadrant are not in this range that is given, right? Now what we're going to do is we're going to draw a right angle triangle. Of course, the winning quadrant is the fourth quadrant. So I'm just going to do this and then draw my right angle triangle to lie in that fourth quadrant, right? This is basically how this thing actually looks. So someone is probably asking, where is this x? Well, x is an angle that is very much in the fourth quadrant. That's what your angle x is, okay? It is bigger than 270 but smaller than 360. So it lies in that quadrant, right? Now, we're now going to start labeling the sides of our triangle, okay? From what we know, cos is x over r, so or adjacent over the hypotenuse, right? Adjacent over hypotenuse. So clearly that 4 that you see over there will be the label on the x-axis, and our hypo, aka the hypotenuse, is 5. So I'm just going to put 5 here. Now, according to the theorem of Pythagoras, we can actually find the missing side here. And I was there when Pythagoras, a long time ago, said if you take the square on one side, add it to the square on the other side, you're going to get the square on the hypotenuse. So according to this, it's basically going to lead you with the number that says y squared is 5 squared, which is our radius, minus 4 squared. And that's going to be 25. 25 take away 16 is going to leave you with a 9. Now, this is where some of us mess it up. Y squared is 9. If you take the square root of both sides and you just leave it as that, you'll notice that you're going to end up with an answer that says y is equal to positive 3. And that right there, beautiful people, is a big flaw. Why? Because if you're looking at the position of this quadrant, you will notice that all y values are below the x-axis, so we're expecting them to be negative. So that notice immediately that you made a mess by not putting plus minus where you took the square root. And then instead of taking the positive version of that, we'll just take the negative one, because then that literally tells us that the y value has to be positive. And we can just delete this one and then have a little nice smiley face that tells us, oh yes, y is going to be negative. So our number here is just going to literally be negative 3. Now, once you've got all the sides of a right angle triangle, you can do anything they want you to work with. So what do we have here? They have 3 sine of 2x. Now we have to expand it because this diagram was not created for double angles. The question is about a double angle. If the diagram was about double angles, then we will literally just read off it. But since this diagram is created for 1x, but the question is about a double angle, you need to expand it so that it talks to the diagram. So that means I'm just going to say that is going to be 3 multiplied by, what is the expansion of sine 2x? That is 2 sine of x multiplied by the cosine of x. So literally this part comes from the sine 2x. Okay, so 3 is a number, multiplied by 2, which is a number, multiplied by sine of x. Now we're reading sine from the diagram. What do we know? We know that sine is y over r, or opposite over hypotenuse. So that's going to be negative 3 divided by 5 times cosine of x. It should be adjacent over hypotenuse. We already know what that is because it came with the question. And then from here, it's just a matter of just multiplying all these things up. I don't know what you're going to eventually end up with. I think it's just a matter of taking that 6 that you have, which comes from 2 and 3. You multiply that with 3, and you also multiply with the 4 on top, because you always multiply the numerator and the numerator, and then you multiply the 5 and the 5, which gives you denominator by denominator. Eventually, you'll end up with a negative answer that happens to be 72 over 25. And that, beautiful people, will be the solution to that little part that you have over there. Right. Moving right along, this is trigonometry, a very beautiful, beautiful concept. It may be challenging, so I hope by the end of this session, you guys will be feeling much better about dealing with general trigonometry. They actually always test the same thing all the time. If you understand how to handle what we have in front of us now, there is no question that will give you a challenge. B says, determine the general solution for x if 7 sine 2x is equal to cos 2x. Now, if you're not awake, you might look at the fact that these are double angles and try to expand them. I know this is 2x, so in our mind, we're already thinking, let's expand this according to the expansion of a double angle. But if you look here, you'll notice that you also have another double angle. That means we can just be smart about this whole thing by dividing both sides with cosine of x. What are we doing? We're trying to change this to a single trigonometric ratio. So if I divide on the left-hand side by the sine of 2x and divide on the right hand side by the sine of 2x, I am not going to go anywhere. because sine of a sine is going to give me 1, but cos of a sine is not tan. It's the inverse of tan. So you don't want to put yourself in that position. Just be careful about the decisions that you're taking, beautiful people. So what I'm going to do, I'm going to say if I have 7 sine 2x is the same as the cosine of 2x, I'm instead going to divide both sides by cos 2x and divide this side as well by cos 2x. That's going to cancel. I'm going to get a 1 there, and that's going to give me the tan. So I'm just sitting with 7 tan of the same angle. As long as the angle matches, it will convert to tan equals to 1. So you'll notice that the tan 2x gives you 1 on 7. Okay, now we're looking for the reference angle. Remember, keep this as a pack. Do not dismantle this. Don't divide by it. Let it be a group. Keep it the way it is. So I'm going to take the reference angle by taking arctan of that. So our reference angle from this story is going to be something awesome. Let's get the calculator. All right, so we're looking for tan. So I'm going to press shift and we look for the tan pattern. You press tan, you'll see it says arctan. Now we're looking for arctan 1/7. So you'll have a 7 on the denominator. Okay, if you do that, you're getting 8.13. That's 8.13. Okay, to 2 decimal places. So 8.13 blah 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 degrees is basically your reference angle. It's not the solution. Now you go and check the quadrants where tan is positive. And you'll agree with me that tan is positive in quad 1. So one of our answers is coming from quad 1 and the other answer is going to come from quad 3 because that's another quadrant where tangent is supposed to be positive. So we're looking for 2x. Remember I said take it as a pack. So if you're taking it as a pack, I need the whole thing with 2 on it. I'm going to put it there and work with it from there. So look at this, 2x, not x. 2x, not x, equals to what? Equals to whatever you have if we are dealing with the first quadrant, so that's 8.13 degrees. Or 2x equals to 180 minus. So you have to take 180 and subtract that because all quadrant, not 180 plus, Schofield, 180 plus, not minus. Third quadrant, it's 180 degrees plus whatever the reference angle that we have. Let me just call it, hopefully it's going to come back with what we have. Yes, it is 188.13. So 188.13 degrees. Now the biggest mistake you can do is start dividing when you're here. You don't have to do that. Remember, we are looking for a general solution. So respect that first. So let's convert it and get it to be general. All right? How do you make it general? You add the green stuff. What's the green stuff? So you have to say plus k times, not 360, it is tan, plus k times 180. Even this one's going to be plus k times 180 degrees, right? Now, after converting it to general, this is where you can now divide both sides by the 2 to get the x to be the subject of the formula. So just be careful of these errors. We see them all the time. Do make sure that you are not that person who's making this mistake. You are watching Tenfold Live, so I know you guys are not going to make this mistake. Okay, so 8.13 divided by 2. Let's see what's going to be 8.13 divided by 2. If you take that 8.13, let me just go back to the number that I had. So that 8.13 is the answer that we have on the far right. I'm just going to divide that by 2. What do you get? You get 4.060.7. Okay, so that's 4.07 degrees plus k times. The 180 is also divided by 2. So that's k times 90 degrees. I wrote k twice. So let's remove this one. Plus k times 90 degrees, right? Let's come back to the other one as well. Do pretty much the same thing. That 188 that you have over there with the 13, you divide that by 2, you're going to get a number that is happening to be 94.07, okay? So that's going to say x is 94 point, okay, that's actually 94.47, yes, 07. Okay, 07 degrees plus k times 90 degrees. When you do 180 divided by 2, where we don't have to write the word where, k is the element of integers, but you really have to write this part. If you don't write it, we're going to be in a lot of trouble. Right. Then we have an identity. Oh, my favorite part. Identity. We are required to prove that cos 2 theta plus 1 over cos theta plus 2 tan theta times sine theta equals to a over cos of theta, where a is a constant. Determine the value of a. This is a very smart way of asking you to prove an identity. Now, I don't know if you guys realize this, but if you took the stuff on the left-hand side, right, and you simplify it, you're going to end up with something that looks like what you have on the right-hand side. However, on the numerator, you're going to have a constant, and that constant is the one that the examiner is asking for. right? That's the one that they're asking for, right? So let's do that. How do you prove identities? I'm going to take the stuff on the left-hand side, all right? That's the expression on the left-hand side. We see left-hand side equals to the cosine of double theta. We have to add 1 on that, divided by the cosine of theta, and we have to add 2 tan of theta. Okay, I don't know if we're going to have enough space, but we're going to find a way around this, guys, together, or we'll be able to actually nail this. Right. Now, there's a couple of things that I can change here, beautiful people, because with identities, you never know where to begin. I think we all agree that the tan theta can be changed to sine of a cos, right? That one is not a train smash. However, what you have on the far left, that cos 2 theta plus 1, is always a problem. Now, don't be shy, guys. You can choose one version of the expansion of cos. Remember, there's 3 ways of expanding it, right? There's 3 ways, and all those 3 ways are available in the information sheet, right? So you can pick any one that you like, any of those 3. However, the idea is always to pick the one that will make sure that you get rid of the plus 1 that you have over there. So the one that I'm picking is the one that has a minus 1 on it. And that is going to be the one that says 2 cos squared theta minus 1. That's the expansion of the double angle of cos. Okay, I'm dividing this by the cos of theta. And I'm sure you can see that the minus 1 and the plus 1 are going to sort each other out beautifully there. All right, cool. Now I'm coming to this guy over here. I've got 2. But what is tan? Tan is just going to be sine theta divided by the cosine of theta. And that still needs to be multiplied by whatever you have, which has always been sine of theta, which you can change to over 1 if you want to force this part to be a fraction so that it matches what you have here. Since we know when you multiply, you always multiply numerator, numerator, and then you also multiply denominator, denominator. Right. Now, on the first term, you've got the situation where you can basically cancel the 1s, and if you do that, you're going to have 2 with cos squared, okay, and I'm going to write that on papers. I've got 2 here, okay, that I want to keep, and then I've got that cos squared that I want to keep as well, okay, cos squared theta, the 1s cancel, divided by, I'm going to maintain my cosine of theta here, add with, right? Now, go back to the right-hand side. You've got 2 times sine times cos. You multiply numerator and numerator, you get another 2, okay? I'm trying to be just innovative here, and this coloring scheme is just messing with me. That's going to be 2 sine squared. We have to divide by what on the numerator? That cos comes back at the bottom with cos and cos. All right, now, if the denominators look the same, mathematically, we know that we can just keep one of them. So that's going to be cos of theta. On the numerator, you've got 2 cos squared plus 2 sine squared, which you can take the 2 out as a common factor, and then you're going to have cos squared remaining, okay, and the sine squared remaining as well. So sine squared plus cos squared is simply going to give you 1. Somebody's asking me, what happened there? 2 times cos squared will take you back to 2 cos squared, and 2 times sine squared will take you back to sine squared. That 2, the sine squared and the cos squared will just give you a number 1, and then I'm sure you guys can agree with me that if you continue on the numerator, you're just going to have 2 times 1, which will just leave us with 2, okay? Let's put the answer there. It will say the answer is 2 over, and then on the denominator, we're going to have that cos of theta as what remains. And if you compare what we have with what the examiner was actually talking to us about, which is this part here, the part we've got over here, right? If you compare that, you can see that they look exactly identical. That means we can all see that if on the denominator they're both cos's, then it means on the numerator we're going to have the number a, which happens to be 2. Therefore, the conclusion is just a is going to be equal to the number 2. Right, so that's actually a very beautiful question that is based on proving identities. Absolutely awesome. I hope you saw how to handle identities. Always change all the double angles when it's necessary. If you're changing the one of cosine, pick the one that has a 1 on it. That will cancel any other constant that you've got in your expression, right? Tan is always sine of a cos. If you can move away from tan to sine of a cos, you can always get yourself back if you ever need to do that. This is Tenfold Live. We're coming back with a lot of very exciting content. There's the geometry question you don't want to miss out. Stay tuned, we'll be right back.
Did you know that 1.3 million Earths could fit inside the Sun? While our Sun is only technically an average-sized star, it is gigantic when compared to the Earth. The Earth's diameter is just under 12,800 kilometers, easily dwarfed by the 1,392,000 kilometer diameter of the Sun. The Sun is so big that about 1.3 million Earths could easily fit inside it.
No one ever asks why we do the weird things we do. Like, why once is never enough. Or doing 2 trips is just one too many. Why do we, before we use these, or say 5 when we mean 20? Why do we have second thoughts? And think that lift buttons make them go faster? Why don't we walk there? Cross our fingers, touch wood, and struggle to hide our true feelings? At Liberty, we want to know all the weird and wonderful things that make us human, because human beings, being human, are what we make financial solutions for. Liberty, in it with you.
Welcome back Tenfolders, to a show that is proudly brought to you with lots of love by Liberty. A very special shout out always goes out to Liberty for affording us this opportunity to share all this awesome content that we're sharing with you guys. This is Tenfold Live. This is the Express edition, where we are looking at math, revising paper 1, paper 2 concepts. Anything that you want us to look at, please keep sending those questions through. Someone is asking, how can I do that? Just go to your App Store. If you get to that App Store, look for what we call the Tenfold Education app. It's an awesome app, packed with a lot of very useful resources, guys. You can also stream the show live, send questions to us, and also watch more videos that we've got on content that will help you build yourself up. Perhaps you want these questions that we're using here, just go to WhatsApp, guys, and send us a greeting there. There's this, and there's also a whole lot of more information there. Our bot text is waiting with a wealth of knowledge and a lot of very exciting information to share with you. While you're on WhatsApp, go to your status message and also inform all the friends who are not watching that they're missing on the opportunity to actually multiply their content coverage tenfold and beyond. Because on this program, we're nothing but we're here to help you. We're here to help you. We do questions that you send to us. Maybe you want also videos, we've got them. If you go to YouTube and you check our channel, it's Mindset Learn. Like those videos we have there, subscribe to our channel as well, and keep watching as many of those videos as you can. I promise you, by the time you're done, you'll be able to do very well when it comes to your end-of-year exams. The next person who sent us a question here is Amuji. So we're going to check Amuji's question. It's based on analytical geometry, not the easy one. So you don't want to miss out on this. Let's go and check out Amu's question. Okay, so Amuji Mudukanele sent this question. It's based on analytical geometry, and it reads as follows. It says, in the diagram, M is the center of the circle passing through point T, right, with coordinates 3 and 7. RT is a diameter of the circle. Point K with coordinates A and B is a point in the 4th quadrant. Right, 4th quadrant, there's point K at the bottom. Okay, such that KTL is a tangent to the circle at point T. Right, awesome stuff. Okay, so first question says, give a reason why TSR is equals to 90 degrees. Give a reason why the angle that you have at point S is going to be 90 degrees. So I think we all know that if you are dealing with a diameter, the angle subtended by a diameter will always be 90 degrees. And this information comes from Euclidean geometry. We know that theorem that says an angle subtended by a diameter or an angle on a semicircle is going to be 90 degrees. So I'm just going to say my reason is that's because this is an angle on a semicircle. Okay, you can give us that one, or angle subtended by diameter if you like. Also still the same thing, angle subtended by a diameter will always be 90 degrees. I like the second one, honestly, because it helps you remember that if there's a diameter, there's a particular theorem involved or an axiom of importance that you can actually work with. It's actually a theorem. This one is a theorem. Okay, cool. 4.2 says calculate the gradient of the line TS. Okay, gradient of the line TS, that's also Charles' plane. We're looking at the point T, the point S, all have coordinates on them. We're just going to do change in Y over change in X. That's 7 and 2. Okay, so the gradient of the line TS is a joke. It's changing y over changing x. So you just check the difference between your y values. The only important thing is the order, creators. If you're doing top minus bottom, you have to maintain the same energy with the axis top minus bottom. All right, don't mess up the order. So I'm going to do 7 take away 2. All right, that's 7 take away 2. All right, and then on the axis, I don't know what the x coordinates are. I think one of them is 3, and I'm taking away 5. Okay, so 3 take away 5, what do you end up with? I think it's going to be 5 for the numerator and then negative 2 in the denominator. So it's going to basically be negative 5 over 2. Are you happy to see this? Yes, the negative tells me that our line is decreasing. Just check these things to make sure they're making sense. That tells me that we're dealing with a decreasing line. And indeed, the line TS is a line that is going down, okay? It doesn't matter where S is on the Cartesian plane, but the point is we're dealing with a decreasing straight line. Okay, so the answer negative 5 over 2 is actually good news. Right. The next question is asking us to determine the equation of the line SR in the form y equals mx plus c. Okay, oh, this is a nice question. We're looking for the equation SR. Okay, there's SR. Okay. Now, because you're looking for the line SR, this is where the knowledge of Euclidean geometry comes hand in hand and works with Euclidean. You've got a 90-degree angle here. You're looking for the equation of a straight line. The ingredients of finding the equation of a straight line is the gradient of that line and a point anywhere on that line. Do we have either? Yes, we do. We've got the coordinates 5 and 2. Those are the coordinates of the point S. We're looking for the equation of the line SR. Where is the problem? The problem is we don't have the gradient of that line. So we need to find it somehow. If we had the coordinates of R, we could do changing y, changing x, but we don't have that. However, we know that they are perpendicular to each other with the line TS. That means I'm going to steal that gradient and use it to find the gradient of the line that I'm interested in. Okay, and that's where our story begins, 5 and 2. Okay, so let's begin here and do exactly that. So I'm going to say the gradient of that line, the gradient of the line which I'm looking for, which is TS, multiplied by the gradient of the line SR is going to give you negative 1 because those lines are perpendicular to each other. Okay, TS is perpendicular to SR, and we have a reason why. We've already argued this. Now, if you go back and you check the first one that you've got, 7 minus 2 is 5, 3 minus 5 is 2, so you got that negative 5 over 2 as the gradient of the first one. So I promise you the second one that you're looking for will always be the first gradient upside down. Remember, beautiful people, we already know that this one, we worked it out from that previous calculation over there. So that means the second one is going to be upside down. Okay, it's going to be the inverse of it. So instead of being 5 over 2, it's going to be 2 and 5. And instead of being negative, it's going to be positive. So I promise you, if you multiply those two numbers, you're going to end up with the negative 1 that you've got over there. Okay, so we were not really looking for the gradient of this thing. We're not looking for the gradient, beautiful people. We just wanted the equation. It's just that you can't find it without the what's this without the gradient. Okay, so what's the point that we say we're going to use? We're going to use point S, and the coordinates of point S for finding our equation is 5 and 2. 5 and 2. Okay, cool. So we've got 5 here and we've got 2 here. So now I'm going to pull the magic that we've got, y and then m into x minus x1. You can use y same x plus c if you like. It's entirely up to you. Right, so y minus, what is my y1? It's a 2. What's my gradient? It's 2 and 5. X is x. What is my x1? It's a 5. Okay, we're just taking those coordinates of x as x1, of s as x1 and y1. So we see y, you put 2. When you see x, you're going to put 5. Okay, and then you just get rid of those brackets by just multiplication. I think it's going to be pretty straightforward. You go in here, you get 2 over 5x. You go there, you're going to get negative 2. Okay. So this is actually very interesting. Look at what we're ending up with here. Y minus 2 equals to 2 and 5x minus 2. The 2's will cancel each other. Eventually, I'm ending up with the equation that says 2 and 5x. Someone is asking, what does that mean? It means this straight line is going to pass through the origin. The drawing is not drawn to scale. But let's see if it makes sense. Let's see if it makes sense. If you went back up, it literally does. It's just that this drawing is not drawn to scale, but I promise you that line would pass through the origin like that and go all the way to SR if the drawing was drawn accurately. That's basically what you were going to end up with, right? Beautiful question. And I hope you guys understand what is going on when it comes to trying to find the equation of this one. Okay. Now, the last question that we have is based on question 4.4, which says to us here, The equation of the circle above is x minus 9 squared plus y minus 6 halves squared equals to 36 and a quarter. Calculate the length of TR in third form. What is TR? Someone asks. Okay, let's go back and check TR. You go back, you check TR, and you find that TR is actually the diameter. Okay, this is the diameter. Right, this is the diameter. Now, if you have a diameter, obviously the diameter is just double the radius. So that means if I know how long my radius is, double of that is just going to give me the length of TR. So it's not always about the distance formula when you're looking for the length of straight lines. Observe what's going on, pay attention to what is happening in front of you, everything else should just work out beautifully fine. Now calculate the length of TR in third form. According to this story, we know that what you're looking at here is r squared, because the equation is in the form x take away a squared, y take away b squared equals to r squared. So according to this, my r squared is 36 and a quarter, all right? And I think you guys are smart enough to tell me what 36 and a quarter is going to be. It's something that requires you to convert so that you can be able to see what this is actually going to be. And we're not actually looking for r squared. We want r only. So r squared is basically 145 on 4. You need to take the square root of that. Square root of that will give you what the answer is going to be. Okay? And I think you guys will agree with me. It implies that our radius is just going to be the square root of 145 divided by 2, because the square root of 4 is 2 and the square root of 145 is the square root of 145. They said they want it in third form. Okay? Therefore, the diameter, which is just double of that, you just have to double it, is going to just be whatever you're looking at times 2, which means it's going to just give you the square root of 145 in third form. And that, beautiful people, will be the solution to how long the diameter, which is basically the line TR, is in third form. If you're looking for this in third form, the length of TR is just going to be the square root of 145. It's just that we were not asked more questions on this. I was hoping that maybe you will ask us to find the coordinates of R as well, which is an interesting, very interesting phenomena that I'm going to just talk a little bit about it so that you guys, when you're at home and you find yourself in this position, you are going to be able to solve this. It's always about what should I do if I'm looking for maybe something as complex as the coordinates of R. Now, if you want the coordinates of R or any other point where two lines meet, in this case, it's the circle meeting the line. So because the circle and the line meet there, I'm just going to do what we call simultaneous equations. I'm not going to do it because you guys didn't ask for it. I'm just thinking maybe somebody somewhere at home is wondering, how would you find the coordinates of R if they were asking you to do that? Remember, the equation of this is y equals to 2 and 5x, okay? That's the equation of the line SR. And what do we know also? We know the circle is going to look ugly. Excuse that. Sorry for that. It's going to look very terrible, but I think we get the idea. Okay, so at point that those two are equal. And what's the equation of the circle? The equation of the circle is x. I think it's take away 6 squared. And then y, take away a very complicated number. I can't remember what it was. Let's go and take a sneak peek on this. It's that's minus 9 and 6 halves. Okay, that's not a 6, it's a 9. Okay, yeah, but what I'm doing is just simply sharing an idea with you guys to say, in future, if they want you to work out the coordinates of that, don't be scared. It's a very simple story where you're just doing simultaneous equation, because between the blue equation, y is 2 over 5x, and the green equation, x minus 9 squared, y minus 6 halves squared equals to 36 and a quarter, then you can be able to get two answers from that. All you just simply have to do is steal this. In fact, not the whole of it, but just steal the part where it says 2 over 5 at y, so just sub it there to replace that y. You suddenly have an equation that is just a function of x everywhere. I think you guys are very good with doing what we call algebra. You can be able to figure out what the solution is. So it's going to be very simple for you. You'll be able to figure it out. This is Tenfold Live. Thank you very much, guys, for sending through the question that you sent through. It was a very nice question. I hope you learned something from it. We're coming back with more. Don't go anywhere. We'll be right back.
Did you know that 1/5 of the world's fresh water is in a single lake? Lake Baikal in eastern Siberia is the oldest freshwater lake on Earth, originating some 25 million years ago. It is also the world's largest volume of fresh water, some 23,000 cubic kilometers of it, which means that Lake Baikal contains about 1/5 of all the fresh water on the planet.
Welcome back, Tenfolders, and thank you very much for staying with us on the show that is proudly brought to you with lots of love by Liberty. A very special shout out always goes out to Liberty, and also saying a shout out to you for watching the program and inviting as many people to join in who are not watching. Tell them that they're missing out if they're not watching this show. Remember, guys, like we always encourage you, if you haven't done so, on your app store, there's a very useful app there. It's called the Tenfold Education app. Download that app. It will help you a lot in terms of streaming this show live. You can send questions to us, and there's also a lot of very awesome notes and great videos there that are based on the content that you're interested in from grade 10, 11, and 12. It's super useful, trust me. Beyond that, if you go to WhatsApp and you send us a greeting there on the number that's currently appearing on your screen, there's decks packed with a lot of resources as well. You'll get all of the stuff that we're using on today's program and even more past papers and a lot of very useful resources as well. You'll get them and be able to beef yourself up, because it's war. It's war, guys, that you're going to be fighting in your final exams. So you want to make sure that you are armed and you're ready. And if you're watching the program, I promise you, you're going to do very well in your end of the year exams. Perhaps you also want access to videos. We do have them. We have a channel on YouTube. Yes, it's called the Mindset Learn channel. Go there, subscribe, like our videos. Yes, like them and inform as many of your friends to also join in, guys, and be part of the fun, because this is very exciting. And we're doing this specifically for you to try and help you guys to also be prepared for the end of the year exam. So you do want to make sure that you become part of this awesome revision program. Okay, so our next question comes from one of you guys. It's based on Euclidean geometry. Let's go and check it out. Okay, so this one is I think it's just a part of what the whole question was about. I think this person was just interested in handling this particular part. It says to us here in the diagram below, O is the center of the circle passing through points C, B, and H. Okay, O is the center. C, B, and CH are extended to G and E respectively. F and D are points on GE and CE respectively, so that FD will be equal to DE and they'll also be equal to EF. Okay, BD is a tangent. Okay, that's a tangent. So you see, if you make note of this stuff, that's a tangent. If it's a tangent, there's a theorem involved with the tangent. This is equal to this is equal to that. That says something about that triangle, which I'm going to mark in green. So this is a very important triangle. If all sides are equal in a triangle, something special is going to emerge there. If a line is a tangent, there's a theorem involving a tangent that is involved. If a line is the radius in a circle, there's actually a lot of very useful information here. So this part here, I'm also going to highlight it in green. If it's a diameter, it says something about this angle. I'm sure you guys will agree with me that that angle there is going to be 90 degrees. So from the love letter that we have so far, this is the information that we can deduce so far, right? I'm just going to mute the noise so that we're going to get back to this and analyze it together as we're working with it. Okay, cool. So ABH, not A, but it's HBD. Angle HBD is equal to 30 degrees. Where is that angle? Let's put in the information. HBD is this little angle in the corner here. Apparently that's 30 degrees. Okay, useful information. Right, now what can we do here? Prove that CE is a diameter of a circle that goes through C, G, and E. Okay, so we want to prove that the line CE will be a diameter to a circle that currently doesn't exist. If you were drawing that circle, it would look like this. It would look exactly, oopsie, that's actually very bad. Okay, it's just a circle that must pass through that point and this point. Okay, much better than this. Yes. So the point is we want to prove that this line would be the diameter of that circle that you're looking at here. A much better looking version of that, but I think you get the idea. Okay. So yeah, how do you prove that the line is a diameter? If you want to prove that the line CE is going to be a diameter, your job is just to prove that the angle that we have here in that corner is 90 degrees. So if you can prove that this is 90, it's chai. There's nothing else you have to worry about. We're done. As long as we can find the value of that and it comes out as 90, that's conclusive enough that indeed this will be the diameter to a circle that will pass through that. Okay, now let's try it. So the goal here is just to find the value of that angle that is missing. Our goal is to find the value of angle G. If we can work it out, everything else is going to work out fine. So what do we know so far? We know that this is 30 degrees. If that is 30, I think you guys know something about the value of that angle there. It's also going to be 30 degrees via tan chord. So angle C is equals to 30 degrees. Why? Tan chord theorem. The angle between the tangent and the chord is equal to the angle subtended by the chord in the alternate segment. Now, one of the most important principles I encourage everywhere I go is the principle of update. Update, update, update. I got 30, immediately put it in the drawing and then see how much you have. Now let's go to that triangle on the far right. I'm going to call it the green triangle. Okay, that green triangle here is what we call an equilateral triangle, aka equiangular. So because it's equilateral, it means all the angles are also going to be equal. That's why we also call it an equiangular, and they will all be 60s because angles must add up to 180 degrees. So I'm just going to go there and call angle E. Angle E is going to be 60 degrees. What's the reason for this? This is an angle of an equilateral triangle. Angles of an equilateral triangle are all equal to 60 degrees if you add them all up. Now, what do you notice? I've got 60s, I've got 60s. I'm going to delete the other 60s because you have seen them. I just want to keep the important 60 only, which is the yellow ones, okay? I'll just write the other ones in green. Maybe you want them. There they are. There's the other one. We are happy with that. But I want you to focus on the big triangle now. We will call it the yellow triangle. If you focus on that big triangle there, I've got one angle which is 30. I've got the other angle which is 60. So obviously, the missing angle is going to be 90 degrees over there. Now, therefore, angle G equals to 90 degrees. Okay, why? This is the sum of interior angles of the big triangle. Be nice, name it. It's actually CEG. Okay, CEG. Okay, therefore, that line CE is a diameter. Question done. Therefore, CE is a diameter. Y of circle CEG. Because this is the mathematical symbol for because. Yes, it is. Yes, because converse angle on a semicircle. If an angle on a semicircle is 90, then that means you are dealing with a semicircle. If the angle is 90, that means that it's going to be subtended by a diameter to a circle that passes through those 3 points that you have over there. Right, that will be the end of this part of the question. There's also another nice question coming that you don't want to miss. I hope this one has opened your eyes as well. We'll be coming back with our last question. We'll be right back.
Want to catch up on some of your studies? Join Mindset for late night studies. Monday is mathematics, Tuesday is physical sciences, with life sciences on Wednesday and accounting on Thursday. Friday is English, maths literacy on Saturday, and Sunday is a good day to catch up on geography. Every day from 9 p.m. till midnight, and again from midnight till 6 a.m. Late night studies, only on Mindset.
Did you know that crocodiles will swallow stones to assist digestion? Crocodiles will sometimes swallow stones to assist with digestion, as having stones in their stomach helps to crush and grate their food. This is particularly useful as crocodiles tend to consume their prey whole. A swallowed stone is called a gastrolith, and they may remain in the crocodile's stomach for years.
Welcome back, Tenfolders, and thank you very much for watching Tenfold Live, the best show in the land. Yes, proudly brought to you by Liberty. A very special shout out always goes out to Liberty, guys, and thank you as well for watching the program. It's always nice to have you sending us these questions that you're sending. So we love you so much. We have a special app for you. If you go to your app store and you look for what we call the Tenfold Education app, it's got a lot of very useful resources, guys, that you can help yourself with and use as you're trying to practice for the end of the exams. Beyond that, maybe you want access to more material, the access with a wealth of resources as well. Just send a greeting on WhatsApp and the number is currently appearing on your screen. There'll be a lot of things that are sent to you guys. You can just play around, select the stuff that you're looking for, and I promise you'll get exactly what you want to try and beef yourself up. Beyond that, if you go to your YouTube channels and look for the best one, which is Mindset Learn, that's where we are found. Subscribe to us, to our channel, and also like our videos and watch them with as many people as you can. Invite them to also join in as we are doing the Express edition. This is the revision one where we are looking specifically on revising concepts on paper 1 and paper 2 using questions that you send to us. So I can't wait for the next one. It's a very exciting question, guys. It's also more on Euclidean geometry. Let's go and check out what this one is about. All right, so this one says in the diagram below, okay, O is the center of the circle passing through the points B, C, D, E, and F. BD is a diameter, okay. DFE is x and BCE is 2x plus 6. Question, find the value of x. Okay, so let's just try and see how much damage we can do on this one. Now, if you look close at what we have here, I'm just going to say, okay, let that be x. I'm not letting it be x. We're told that DFE is going to be x, and then they're saying to us here BCE will be 2x. This is the part over here will be 2x plus 6 degrees. Okay, so those are the two things that I have here. Right? And I'm asked to find what the value of x is going to be. Okay, now I need to find a way of connecting this stuff. I've got stuff on x and stuff on 2x plus 6. And I've got a diameter as well. And I think you'll agree with me that that diameter is useless at the moment. The only way the diameter will be useful is if we construct and join point C to point D. If you draw that chord that was not there, suddenly that diameter speaks something to us. It creates an awesome angle, which is 90 degrees. And there are two things that are existing here. Two things. One, the chord DE, which I'm going to draw in blue, this chord over here, right, starts subtending two angles. It subtends the angle X. It also subtends the angle DCE at the bottom. And what do we know about the relationship such as this one? We know that the angles that are subtended by the same chord on the same segment are going to be equal. So that means that here we're going to have the value x as well, right? That's what is going to happen over there. So that's where I'm going to first of all begin. And I'm going to just ask nicely, construction, please allow me. I know this doesn't happen a lot on NCS exams, but in IB, we get it a lot. Join C to D. That's the first thing that I'm going to ask them to let me do. And then therefore, there's going to be a little x created there. So that means angle DCE will be equal to the x that you've got at the top. The reason is these are angles on the same segment or angles subtended by the same chord. Angles on same segment. Okay, beautiful stuff. Right. Now I've got that angle over there, so we're going to finish this off in a very, very powerful way by looking at the fact that you've got a diameter. And what do we know about a diameter? All we know is that an angle that is subtended by a diameter in any circle, if you've got a diameter there, the angle that is sitting on it is supposed to be 90 degrees. That means the combination of that group of 2x plus 6 as well as x must give us 90 degrees. Okay, so I'm going to say angle C, the whole of angle C. Angle C, all right, is equal to 90 degrees. What's the reason for this? That's an angle subtended, okay, by a diameter. Once I've got that, all right, once I've got what I'm looking at over here, I can now start writing what we have. C is basically 2x added with 6 degrees, plus the other piece is actually x, and all this must just give me 90 degrees. This is very common when you're doing IEB, so don't be scared of construction if there's a need, but I think in NCS, the chances of that happening are very minimal. So I've got 2x and 1x, which gives me 3x. I'm now going to take the difference between 90 and 6. When you subtract 6 on both sides, you're going to get the number 84 degrees. So I'm just going to divide both sides by 3. If I divide on the left by 3 and divide on the right-hand side by 3, you're just simply looking at 84 that you need to divide by 3, and I'm sure it's going to give you the number 28 degrees. So that's the value of x. X is just going to be the number 28 degrees. All right, and that actually literally brings us to the end of this particular question. There is not much that you can do on this except find the value of x. I think if you wanted to find more stuff that you've got here, you can just simply be able to continue and work with what you have here. I think there's actually more things that you could do if you've got what the x value is. You can do even the calculations or trying to figure out what the other angles are, provided that you are asked to find what the actual numerical values of these angles are. So what is the lesson from this? Do not be scared to construct. In this case, the diameter was useless without that construction. There's one question I saw where they said, if you've got a circle and they say, prove that if you could put 4 points here, maybe you put a point here, you put a point here, you put a point here, and then you put a point. They just say that put point here, no construction, no connection. They just put them and they just say, prove that if you had to join all those 4 points, you could create 2 triangles that are similar to each other. And I'm sure you can see if you do this, and you do that, and you do this, and you do that, you literally get 2 triangles that you can prove that they're similar to each other by doing all the concepts of similarity that we all know about, and we're very good at handling. So I think that actually opens up your eyes when it comes to this. We've got more shows that are still going to be coming, guys. Thank you for joining this particular edition, which I call the Express Hybrid Edition of Tenfold Live, where we are looking specifically on concepts from Paper 1 and Paper 2. Thank you very much for joining us. Thank you to Liberty for sponsoring our program. A special shout out also goes out to our production team for working under pressure to help us bring all this to you guys at home. Until we meet again next time, from me, bye-bye.
What's up, peeps? Welcome to Moby School. We are here to make sure that you, yes, you get all the marks that you deserve on the go. We're here every Mondays to Fridays from 2 to 3 p.m. only on Mindset Learn TV. Now, this is a whole hour worth of revision just for you, and I hope that you've got your notepads and your pens ready, and that you and your study group are game for today's revision session. Now, my name is Joe, and just like you, I am also Metric, and I'm here for a whole hour to make sure that I ace my final exams, and I hope that you will be doing the exact same thing. Now, do remember that we love hearing from you guys, so log on to our Facebook page, which is www.facebook.com/MobySchoolSA. Drop us your comments, like our page, share the page, and even spread the Moby School family even bigger. Now, isn't that cool? Yep. Yes, it is. Now, do remember that you can catch us here for a whole hour of revision session where all of our awesome teachers come right here to help you guys revise. So on that note of the first revision session, let's head straight to our teacher.
Okay, this is Maths Paper 1. It's 3 hours. Just a few important things before you write Mathematics Paper 1. Remember, they will tell you in the instructions, you know, the number of questions there are. And in this particular exam, there are going to be 10 questions. And they will say answer all the questions, show all calculations, diagrams, graphs, and ensure that you round off correctly in the paper. They normally say to 2 decimal places, so watch out for that as well. You may use a scientific and approved scientific calculator, non-programmable and non-graphical, so you can use the normal calculators as well. And if they say do not use a calculator, they'll say without using a calculator, so watch out for that as well. Okay, and so watch out your rounding. Diagrams are not always drawn to scale, so don't go and use a ruler now and measure things. Okay, they're not always to scale. Okay, and this is important. Number your questions correctly, because remember, when they're marking the matric final exam, the important thing is that you work to please the examiner, if I can use that. You know, set your paper out correctly. You know, if it's question 1, 1.1, make sure that it's clearly indicated. Okay, and write legibly and neatly and clearly so that the examiner knows what you're writing. Don't just scroll things down, because otherwise you lose marks. And remember, those markers are under pressure. So what you want to do is you want to make sure that you present yourself clearly, legibly, number the questions, and don't go and lose marks for notation or rounding off. Okay, so let's kick into Mathematics Paper 1. Here it is. And we're going to start off with the first question, which is typically algebra. It says they solve for x. Now notice, rounded off to 2 decimal places where necessary. Okay, now if you look at this, you've got this equation where you've got a denominator. So what are we going to do first? We're going to factorize the denominator. So take out a common factor of x. And what is the lowest common denominator? Well, it's x plus 2. So if you multiply both sides by the LCD, I'm just going to write that down. You can actually do that if you want to make sure you don't make mistakes. So if I multiply both sides by the LCD, guess what happens? Well, no problem. Then it's going to be easy, because these guys cancel here. The x plus 2 cancels with the x plus 2 at the bottom, and you take the 3 and multiply by x into x plus 2. And of course you have it there for x squared minus 4 equals 3x into x plus 2. And what do we now do? Well, we simply multiply out the brackets. 3x times x is 3x squared, and 3x times 2 is 6x. And guess what? We're going to have a lovely little quadratic equation. Okay, so what do we now do? Well, x squared minus 3x squared gives you negative 2x squared, and then you bring the negative 6 to the left, negative 6x minus 4. And something that I'd always recommend with trinomials, you can use the quadratic formula, minus b plus minus the square root of b squared minus 4 is ac over 2a. There is a formula sheet, by the way, as well, and they put these formulas on. So for any quadratic trinomial, you can use that formula, but in this case it's pretty straightforward, and all you have to do is divide everybody by 2. That makes, I always like the number next to x squared, the coefficient, to be 1, because then it's easy to work with. So if you divide everybody by negative 2, Well, we get x squared, negative 6 over negative 2 is 3, and negative 4 over negative 2 divided by negative 2 is 2. And that is a very, very straightforward little trinomial there. Okay, so let's just erase the LCD there, make it neat for us. Okay, and what do we have? Therefore, x plus 2x plus 1 is not a simple factorization. And then x is equal to negative 2 or negative 1. Okay, and that is the solutions of the quadratic equation there, which you can actually use the quadratic formula and it just gets you the marks. Now, be very careful, especially in this new curriculum. I want you to look at these two values here. Now, look at x equals minus 2, x equals minus 1. I'm going to make a statement here. X cannot be equal to negative 2. And the reason for that are the restrictions, okay, and it might be worthwhile if you actually at the beginning say, look, x cannot be naught and x cannot be negative 2. Why? Because if x is naught, you have naught in the denominator. That's a huge problem. You cannot divide by naught. And likewise, if you have a look here, if x is negative 2, negative 2 plus 2 is naught. Again, 0 in the denominator. Division by naught is not allowed in maths, okay? And therefore, it's very important when you've got x's at the bottom to check those answers. Now have a look. We say, but x cannot be equal to negative 2. Very important. What I emphasize to students, don't go and put a little line through the negative 2 at this stage. You must state, but therefore you get the two solutions, then you say, but x cannot be minus 2, and therefore the solution can only be x is equal to 1. Why? Or minus 1, because that works. Okay, and there is your only solution. Watch out for that layout. It's so important that. Okay, nice easy question to start the paper. You get your marks. Chop chop. Okay, next one.